Here is our hypothesis again. We're saying in the null hypothesis that there is no difference in the mean purchases for the two groups. And then the alternative is that there is a difference. And our calculated value is 3.38. And as we determined in the previous video, that is a large t value. So in this case, we are going to reject the null hypothesis. And when we reject the null hypothesis, when it comes to looking at means, we always look back at the means to describe the difference. So here's what we got, if you recall. It was 5.05 for the young professionals, and then we have 4.23 for the mature professionals. Now, this is a typical thing that students do is when they do an independent samples t-test, they stop at we reject a null hypothesis, and then that's it. Like, whoa, there's more to it than that, right? You have a manager, in this case, if you recall, your manager wants to know what kind of images to use in an advertising campaign. And it's not going to be helpful if all you say is, we reject the null hypothesis. There is a difference between the two groups. And we're like, okay, so what does that mean? So you have to go a step further. You have to write your interpretation or share your interpretation. And this is what it's going to be. So looking at our sample here, we see that young professionals do purchase more than mature professionals. So we're going to say young professionals make more purchases in a week compared to mature professionals. That's it. So you can tell your manager, let's use young professionals in our imagery because they make more purchases. Now, we know the difference between the young and mature from the sample, but we can't say that that would be the case for the population because remember, samples lie. They contain error. So to find the difference in the population, the best that we could do is to relay that via a confidence interval. And at this point in your analytics courses, you've seen two other confidence intervals. So you have a confidence interval for the mean, and then you have a confidence interval for the percentages. Here's a third one, confidence interval for the difference between the means. And we can get the difference from the sample by simply subtracting 4.23 from 5.05. So that's where 0.82 comes from. But that's the sample. So we need to find the confidence interval, and we're going to skip the formula because, right, we got statistical software for that purpose. So when we run it through R, this is what we get. 95% confidence interval for the difference between means. Well, it's 0.3 minus 0.37 to minus 1.309. But remember, right, the positive, negative, that's arbitrary because it depends on what we consider the first group and the second group. So we can say that the difference is 0.347 to 1.309 coffee purchases. Now, here's what I want to say about that. When it comes to communicating the results, you want to ensure that you include the unit of measurement. It's not going to be enough to tell your manager that the difference is 0.347 to 1.309. Like, okay, what does that mean, right? So really what your communication should be when sharing the confidence interval would be this sentence right here. In the population, The difference between young and mature professionals' coffee purchases could be as small as, and this is where we'll put 0.347 to 1.309. And really, it would be even better to say purchases per week. All right, in the next video, let's go over the statistical output.